students. Today we will discuss the line integration, surface integral and volume integrals and two important theorem, that is Gauss's divergence theorem and Stokes theorem. So first we will discuss the basic thing, that is ordinary integral of vectors. That means suppose there is a vector r and u is the scalar variable. So for component we can write that is I cap r1u plus j r2u plus k cap r3u. That means the vector is r and it has single scalar variable u, and r1 r2 r3 are the continuous in a specified interval. So RU du, that means the integration RU over du, that is called indefinite integral. And let us explain it using a simple example. That means all of you know that the Vt velocity is equal to rate of change of displacement dst dt. So here t is the scalar variable and Vt dt, integration Vt dt is equal to integration dst dt dt. So and the answer is st plus c, where c is the integration constant. So if we define the upper limit and lower limit, that is integration b to a, so that is sb minus sa, then it is called definite integral. Now we will discuss what is line integral of vectors. So the integral which can be performed along a line or a curve of any function, and it has continuously varying value. So it is called the line integration or line integral, and this is very important to solve the real life problems in physics like work done, electrostatics, fluid flow, Biot-Savart law, or Ampere-Circuitos law, etc. So line integral, it is a of a vector field. It plays a very important role in vector calculus for describing the Stokes theorem. Now we will start the line integral of vectors. So let us understand the mathematical description of line integral. Suppose we have a line or a curve C joining the points P1 and P2. So let's say the position vector of any arbitrary point of the curve is r is equal to xyz. So r is a function of a single variable u, and it is continuous. It is important to mention that the RU is a continuous derivative along the curve, and dr is representing a small elemental length on the curve, and direction is along the tangent of the curve at a particular point. So now let's consider a vector A which is a function of position xyz and also continuous along the curve. So the integration uh, then the integral of tangential component of A along C from P1 to P2 is, that is P1 to P2 integration A dot dr, that is the integration A1 dx plus A2 dy plus A3 dz. And the example of line integration, that is the work done, that is if a force F or A is applied on a particle moving along C, this line integral represents the work done by the force. So this is the open line integration. That means the curve is it has a P1 P2 in final and starting point. The next point is closed line integration. That means suppose this curve is closed, that means a particle or a curve is starting from P1 to P2 and then it goes again from P1 to P2. So if the C curve is closed, then it is called the closed line integration is closed line integration C A dot dr, and this is the open line integration. Next, we will discuss the two important theorem of line integration. So first theorem, that is, if suppose A is a vector, so we can write it A is equal to del phi, where phi is a scalar field. That means gradient of a scalar field that is expressed by a vector. So P1 to P2 integration A dot dr, it is independent of path C in the joining region joining P1 to P2. It only depends on the final and initial point. So that is the theorem 1. And for theorem 2, that is closed line integration A dot dr is equal to the 0 around any closed curve if in such a case A is called conservative vector field. So what is conservative vector field? So conservative vector field, that means it is equivalent to the conservative forces. The force is called conservative if the work done by the force is dependent only on the initial and final position of the body and does not depend on the path followed by the body. That means work done by the conservative force in the closed path is always zero. The example is gravitational forces, electrostatic forces, and they are also irrotational vector also, because the del cross these vectors equal to 0. Now look at this figure. So there is a initial point is A and final point is B. So a particle, suppose it is going from A to B, so it can take either path 1 or path 2 or path 3. So for conservative forces, all the this is path independent. That means W1 is equal to W2 is equal to W3. That is conservative forces, where the energy will be conserved. Whereas for non-conservative forces, that means the frictional force, viscous force, or air resistance force, it has some energy or loss. That means it is not conserved, and this is path independent. That means path dependent. That means if there is a friction in this path, then the W3, the work done will be more with respect to the W1. That means it is not equal. So for non-conservative forces, the work done is path dependent, and the closed uh, path integration is not zero. An example is frictional forces, viscous forces, air resistance forces, etc. Now coming back to this theorem. So for conservative forces, the line integration P1 to P2 A dot dr, it is independent of the path and it only depends on the initial and final point of the vector. And the closed line integration is always 0. That means suppose a vector is conservative, then A is equal to del phi. So del cross A is 0, and A vector is also called irrotational vector. Now we will discuss the surface integral. So suppose there is a surface S, that means a curve is closed and it is a surface S, two-sided surface, and n cap is a unit normal at any point. So upper surface is the positive side and lower surface is the downward side. Upper surface is the positive side and lower surface is the negative side. So the ds vector is n cap ds. So the electric lines of forces or magnetic lines of forces, that means can be explained by V in general. So the flask, the V dot ds, that is the flask of V over S, the surface, that is the surface integration V dot ds. And the open surface integration denoted by this, and the closed surface integration, that means when the surface is closed, that is denoted by this symbol. Now the volume integration, what is this? So suppose this is a surface and here the enclosed volume is d tau. It is equal to dx dy dz, and the volume integration is triple integration a dot d tau. And what is the example? That means total mass, that means rho is the mass density, into the d tau. If we integrate, then we can get the total mass of any system. And volume integration a dot d tau, that means if we multiply the mass density into the velocity uh, over the total volume, then we can get total linear momentum. Now, the Gauss's divergence theorem. It simply relates the surface integration to the volume integration. What is this? Suppose the surface integration, this is the surface integration integral of the normal component of a vector A, that means a vector field which is a function which is a function of position with continuous derivative taken over a closed surface. That means this is a closed surface and this is the lines of forces. This is the A vector. So A dot surface integration A dot ds is equal to the integral of the divergence of a vector A taken over the volume bounded by the surface. That means here this is the surface and this S, and this is the enclosed volume V, and d tau is the small elemental volume, that means d tau is equal to dx, dy and dz. So and A vector is the passing through this surface, closed surface where the volume is V. So the surface integration, closed surface integration A dot ds is equal to the volume integration divergence of this vector field. This is called Gauss's divergence theorem, and it is said that total flux of a vector field A through a closed surface equal to the total divergence of the vector field over the volume enclosed by the closed surface. So this is the Gauss's divergence theorem. Now we will discuss the Stokes theorem. It is relating to the, it relates to the line integration to the surface integration. So what is this? Suppose there is a curve C and there is a path closed S. So the line integration of the tangential component, the line integration of a tangential component of a vector field A, that means the line integration, closed line integration A dot dl is equal to the surface integration of curl of a vector taken over any surface S, where C is its boundary. So suppose the girl is running in this path, so the n cap direction is in the upward direction, and if A is the lines of forces or flux flowing through this surface, but suppose the girl is moving in opposite direction, then the n cap will be in the downward direction. So C is traversed in the positive direction, and the direction of C is positive if an observer walks on the boundary in such a way so that the surface on his left anti-clockwise and his head positioning in the direction of positive normal to the S. But if the girl is running in opposite direction, then the n cap will be in the downward direction. So the Stokes theorem is related to the line integration to the surface integration. Now today we will end here. Thank you so much.